Welcome to Pre-Calculus Trig, Section 2.2 on graphs of the secant and cosecant functions. So the first thing we're going to do is learn how to construct the graph of the parent function for the cosecant, y is equal to the cosecant of x. So these are these blue pieces right here. These all comprise the cosecant graph. The cosecant graph is also periodic and has a period of 2 pi. So we'll get to that in a minute. So in order to construct these blue segments of the cosecant graph, we first graph the sine of x. And the reason we do that is because we can use that to figure out where these blue parts lie on the xy plane. So the cosecant of x is 1 over the sine of x. All right? And so if I look at this dotted section right here, we'll just look at one period. This is my sine of x graph. So looking at the unit circle down here, when x is 0, my angle is 0, my sine is 0, so that's here. And then when the angle is pi over 2, my sine is 1, so that's this point here. So let's go ahead and put these points on here. And we learned how to do this in 2.1. So then when the angle is pi, we're back to having a sine of 0 again. And then down at 3 pi over 2, my sine is negative 1. So that's here. And then full cycle, one full cycle, at 2 pi, I'm back to 0 again. Right, so I construct one sine wave period here, and then I examine where I'm going to go to 0. And the reason I'm going to do that, where my sine is 0, the reason I'm going to do that is because if y, the graph we want, the cosecant of x, is the same thing as graphing 1 over the sine of x, what that means, wherever the sine goes to 0, we're going to end up with 1 over 0. And that's undefined. So wherever we're undefined, we're going to have a vertical asymptote. So I want to find out where I'm going to draw my dotted lines for my vertical asymptotes. So wherever the sine of x is equal to 0. So the sine of x is equal to 0 here and here, at 0 and pi. So at 0 and pi, I'm going to have a vertical asymptote. All right, so at 0, I've got a vertical asymptote, and at pi, I have vertical asymptote. And if I go around to 2 pi, I've got one again. So these dots that lie right here on your midline are where you're going to have your vertical asymptotes, right through those dots, vertically. All right, so then we know that since the cosecant of x is 1 over the sine of x, at pi over 2, the sine is 1. So we'll have 1 over 1, which is 1. So the sine is 1, and the cosecant is 1. So they share a dot. So they share a dot right here. So they both have that dot on the graph. So we use that to help us know where to start this function, the blue graph. All right, and then we also have a shared dot down here at 3 pi over 2. When the sine is negative 1, then 1 over negative 1 is also negative 1. So the sine is negative 1, and the cosecant is negative 1. So we have a shared dot right here. All right, so we've got the asymptotes and we've got the shared dots. So what we do next to graph these things, so we'll do it in a different color, is we put our pencil on the dot and we head for the asymptote. Pencil on the dot, head for the asymptote. Then also here, pencil on the dot, head for the asymptote. Pencil on the dot, head for the asymptote. So we've graphed one period here where our period is equal to 2 pi, which is the same as the period of the sine function. All right, and since this is a cyclic function, that means it repeats each 2 pi. Every 2 pi, you're going to get the exact same graph. As you march to the left, you march to the right. You can see that here. This and this repeats this, and then you're going to get it again over here, and you could keep going to negative infinity, infinity, and positive infinity. And that's what your cosecant graph is going to look like. So now let's talk about the parent function of the secant. So y is equal to the secant of x. So the secant is equal to 1 over the cosine of x. All right, so we do this pretty much the same as we did the cosecant. All right, so we can construct this graph by graphing the cosine, and this is the cosine graph from 0 to 2 pi, and we learned how to do that in 2.1. So then we draw our asymptotes through the places where your cosine is 0 this time. So your cosine is 0 here and here. So your asymptotes are going to occur at those places because that's where you're going to have an undefined secant. So at pi over 2 and 3 pi over 2, we're going to have our vertical asymptotes. So here's pi over 2, and here's 3 pi over 2. All right? So those are the places where your secant is undefined. Now we're going to have some places where the cosine and the secant are the same, and those are these dots right here. Let's make them blue. These are going to be on the graph of the secant right here in 3 places for 1 period. Okay, so that occurs where at 0 degrees, your cosine is 1. So 1 over 1 is also 1. So your cosine and your secant have the same value, 1. So this dot is on both the cosine graph and the secant graph. At pi, here, your cosine is negative 1. 1 over negative 1 is also negative 1. So they have the same value. The cosine and secant have the same value at pi. And then full circle, we're back to this situation again. So at 2 pi, they also have the same value. So these 3 dots are going to be on the graph of the secant of x. So we graph them the same way. We put your pencil on the dot, and we head for the asymptote. Pencil on the dot, head for the asymptote, head for the asymptote, and head for the asymptote. So this right here, from 0 to 2 pi, is your period. So our period is equal to 2 pi for the secant graph as well. It has the same period as the cosine. So let's talk briefly about why these graphs head up, looking straight up here, like to positive infinity, and also here and here go down to negative infinity, and here go down to negative infinity. Why is that occurring? So let's think about it this way. So it occurs as I'm approaching pi over 2, my secant is getting very large. So if I'm going around my unit circle, my cosine is getting smaller and smaller and smaller. So here's my largest cosine value at 1. My smallest cosine value is 0. So if you get really close to 0 and you're a very, very small number, then 1 over that very, very small number becomes a very, very large number. So that's why we approach infinity as your cosine gets very small. Right, and that's going to occur here as well. So that's why you get this behavior here at the asymptotes. So on the other side of pi over 2, so now you're here, but your cosines are negative on this side of pi over 2. So you're approaching a very large negative value here. And as you approach 3 pi over 2, your cosine is still negative. You're approaching a large negative value here. But then when you get onto the other side of 3 pi over 2, your cosines are back to being positive again. So now, as you get close to 3 pi over 2 right here and your cosines are very, very small, again, you're going this way and getting, you've got a huge positive number again as you get close to 3 pi over 2 on this side. So that kind of explains to you, if you digested that, why these graphs swoop up like this when you get close to the asymptotes and swoop down like this when you get close to the asymptotes. So let's summarize a few things here about these graphs. So you could have your A, B, C, and D in these cosecant and secant graphs the same way you did in the sine and the cosine graphs, and they have the same meaning for the most part. All right, so the cosecant is 1 over the sine of x, and we said that the cosecant is undefined when the sine is equal to 0. All right, and then we said the secant of x is 1 over the cosine of x, and the secant of x is undefined when the cosine is equal to 0. The vertical asymptotes occur where these functions are undefined, and those are the vertical dotted lines that we drew. Now when we talk about this A in front here, on the cosine and sine graphs, the absolute value of that was considered the amplitude. So when we're graphing the construction lines, let me just show you, when we're graphing the construction lines here, these have an amplitude, but these pieces of the graph, that are the actual secant and cosecant graph, are not considered to have an amplitude. It doesn't have the same meaning, because what amplitude really means is the height from the midline of your peaks. So this is your amplitude number, and this is your amplitude number, but it doesn't really make a whole lot of sense to talk about the blue pieces of the graph as having an amplitude. So a lot of times you'll hear it said that the amplitude is considered to be undefined, or in some books you'll see it just, it's not relevant. Okay, so if you're asked whether you have an amplitude for a cosecant or a secant graph, you're going to say it's undefined or it's not relevant. But the multiplier A, the coefficient here in front, does still affect the y values of the graph. It's just not considered an amplitude. Right? The period is the same as with the sine and the cosine. Their standard period is 2 pi. So we calculate it the same way by dividing by the coefficient b, if there's a transformation. The phase shift, the horizontal shift, is calculated the same way as the sine and the cosine, c over b. So if this sign is positive, then you go left. If it's negative, you go right. All right, and then you could also still have a negative in front of the A here, which would cause a reflection of the graph about the x-axis. So a lot of this is the same. So in this example, we're asked to find the period, the phase shift, and the midline. So this problem does have a midline. And so therefore, let's look at y is equal to a secant of bx minus c, we'll say plus d. All right, so looking at where we're given, we've got an a of 3, we've got a b of 3, we've got a c of 6, and a d of 1. All right, so our period is still going to be equal to 2 pi divided by b. So that's 2 pi divided by 3. So my period is 2 pi over 3. So my phase shift is going to be c over b. So I have a c of 6, and I have a b of 3. So I have a phase shift of 2, and then I have a direction here, which was going to be opposite. So I've got negative there. I've got a phase shift of 2 to the right. So that's a horizontal shift, 2 to the right. And then I have a midline out here. So y is equal to d is going to be my midline. My d is 1. So my midline is y is equal to 1. So we're not going to talk about the amplitude. That 3 number does go into how the graph is drawn, but we don't call it an amplitude when we're talking about secant and cosecant graphs. So in this example, we've got this equation here, and we're asked for these 3 things again. So the period, once again, is 2 pi divided by your coefficient b. So in this case, b is this number. There's no c, so c is 0, and d is this number. So 2 pi divided by b, so that's 3 over 13. So we can say this is the same thing as 2 pi over 1 times 13 over 3. So that's 2 times 13 times pi over 3. So this would be my period here. Now my phase shift, if my c is 0, that means c over b is 0 over b, which is 0. So there's no phase shift. And my midline is y is equal to d. My d happens to be -2. So here's my midline. So this is down 2. So we're going to find the same 3 things for this equation. So we have an A, a B, a C, and a D. So for the period, our period is 2 pi over B. So that's 2 pi divided by 2 pi over 3, which is my B here. So that's 2 pi over 1 times, flip and multiply, 3 over 2 pi. So it looks like these will cancel the 2 pi's, so you have 3 over 1, so that's 3. So my period is 3 here. So now for the phase shift, my phase shift is C over B. So I've got a C of 5 pi over 4 over, so that's divide, by 2 pi over 3. So that's 5 pi over 4, flip and multiply, 3 over 2 pi. So I can cross out my pi's. So I'll have 15 over 8, it looks like. 5 times 3 is 15, 2 times 4 is 8. So I have a phase shift of 15 over 8, and I have a negative here, so that means I have a 15 over 8 phase shift to the right. All right, and the last thing is my midline. So my midline is y is equal to d. In my case, y is equal to 2. So that's a vertical shift up 2. So that's what we have, and once again, we're not talking about amplitude. It's not relevant to the graphs of the cosecant or the secant. So in this problem here, I've got a graph, and I want to write the function that gives me the graph. So the first thing that you want to do is draw the midline. So if you examine the graph, you can see that the midline would be right here. And that's going to give you my D. So my D is going to be -2. So this is my midline. Y is equal to -2. All right, so we have D is equal to -2. So from here we can also see that A, this dimension here from the midline to the graph is 2. So we have A is equal to 2. All right, so now let's draw in our construction line for the related sine graph. And the way that we can do that is that let's look at 2 points. So from here to here in the x direction is half of a period, and that's 6 units. So this should be 3 to here, and then 3 to where it crosses, and then 3 to here, and then It's off the graph here a little bit, or 3 to there. So that's one period there. That's one period. So it looks like our period is from 0 to about 12. It's a little hard to read that, so it looks like it's 12. Let's pick 2 other dots, because you got to work with the viewing window you've got, and if you're off the graph, it might be a little hard to read that. So let's find 2 comparable dots that we can read. So I can read this dot off well, and I can also see that the identical piece of the graph, which is there. So if I can find 2 identical pieces, that means I'm repeating again over this amount right here. So that should be also 12. So that's 3, 6, 9, 12. So yes, the period is 12. Or you could also see these 2 pieces up here, which are identical pieces, are going to repeat over a period of 12 as well. That's also 12 units. So you've got to find a place on the graph and then an identical place on the next piece over and count the squares between them to figure out what your period is. That's if you can't read your whole sine wave here. It was a little off the graph here. But we can see that it's 12. So our period is 12. All right. And our period then is, of course, 2 pi divided by b. All right, so 12 is equal to 2 pi over b. So I could say 12b is equal to 2 pi, which means b is equal to 2 pi over 12. So b is equal to pi over 6. All right, so we can say b is pi over 6. All right, so now we just have to find c. All right, so c, if we have a c value, that means we have a horizontal shift or a phase shift. Now, the way to tell whether you've got a phase shift is to look at where your related sine graph starts. So, and if it starts right here on your x-axis, this is my x-axis right here. I mean my y-axis, sorry. This is my y-axis. If it starts right there, which it does, see, it starts right there, there's no phase shift. Your beginning of your period is not moved to the left or to the right. All right, so there's no phase shift here, and let's make a note of that, how I knew that. So I said the sine graph starts at x is equal to 0, so that means there's no phase shift. So if there's no phase shift, then that means c is equal to 0. So c is equal to 0. All right, so we have everything we need now. Let's go ahead and substitute into the equation. So we've got the equation now. It's going to say y is equal to 2 cosecant of pi over 6x, close parentheses, because c is equal to 0, minus 2. So this is the equation that describes my graph, my cosecant graph, which is just the green parts and not all the construction lines here. Okay, last example here, we're going to do something similar, but this time we've got a secant graph. So looking for the symmetry here, I'm going to draw on my midline first. My midline is right here. So that's y is equal to 1. So that means my d value is 1. Because then I could get my a number from the midline up to that point, or you could use the midline to this point, or the other one, it doesn't matter. So that's 2, so that means my a is equal to 2. Now I can get my period by finding 2 equivalent locations and counting the distance between them. So I could see those dots would be pretty easy to count between. So that would be 5 on the left of the y-axis and 5 on the right. So my period is right here. So that looks to be 10. So my period is 10. All right, so I can calculate my B now by saying my period is equal to 2 pi divided by B. So 10 is equal to 2 pi divided by B. All right, so that means 10B is equal to 2 pi. B is equal to 2 pi over 10. All right, so let's reduce that. So that's pi divided by 5. All right, so now I've got my B. My B is pi over 5. Now let's see if we have a C, if we have a phase shift. All right, in order to see if you have a phase shift, let's draw in our construction lines for my cosine graph. So remember, a cosine graph is going to have half of its, half of its hump there and half of its hump here, lower one, like that. All right, and then it's going to go back up there, and then like that. So I can see that I do start right here on the x-axis. Okay, so I haven't pushed, I haven't been shifted to the left or to the right from my starting point. Okay, so another way to know whether or not you've got a C is if you look at this piece right here, you can see that it's exactly centered on that y-axis there. So that tells you that you do not have a horizontal shift. So that means my C is equal to 0. All right, so now we have everything we know. We can go ahead and write the equation by doing our substitutions. All right, so we got y is equal to 2 secant of pi over 5 times x. We have 0 for C and plus 1. So this is the equation that describes our graph. Okay, so that wraps up our examples for graphing the secant and the cosecant. So our next video, we'll talk about the tangent and the cotangent graphs.